Hi, my name's George, and I'm currently working on a game and game engine. The game's called Kernel Panic. The engine is made in C++ using Vulkan for the rendering API and Fmod for the sound API. So yeah, let's just get right into it. First things first. Let me just tell you what the format for the video. I'm gonna show you guys the different features in game first, and then I'll show you guys some code snippets. Let's look at the procedural textures. So the entire game is going to be made using an ASCII shader, which I've developed. So what this ASCII shader does is it procedurally generates ASCII characters onto a given fragment in the fragment shader. So you can see the ASCII shader in action here for the fragments in the environment. Currently that's going to be a 3, although that's one way around. Getting the orientation correct is challenging, but anyway, you can see that there's 3s and dots, and the grayscale. What happens is the grayscale of the underlying texture that we're sampling from, or we take the color of that, convert it into grayscale, and then use that grayscale value to determine which character to display. So for example, if there's a lot of light in a particular area on the underlying texture, that then gets sampled, gets turned into a high grayscale value, and then that might become, for example, like a hash symbol, because the majority of that character is taken up by white pixels, in this case at least. So yeah, it's very basic, just taking a given section of the texture, finding out what the grayscale value is, and then using that grayscale value to basically paint the correct character onto the surface. So most of the aliasing is gone. It used to be horrible. Most of it's gone. I've also got a physically based rendering, a couple of physically based rendering shaders and functions. As you can see, there's kind of metallic look to the floor, and obviously the weapon looks very metallic. There's currently 4 lights. So yeah, that's pretty much it for the ASCII shader. So yeah, the PBR effect, you can see that on the weapon and on the environment as well. If I fire the weapon, you can see the different flash effects also count as a light source. There is an animation system in the game. It uses quaternions. I don't fully understand quaternions, but they're fairly easy to implement in code if you use external libraries for them. So that's what I use for creating the matrices, which in turn transform based on the different bones and bone IDs. They transform groups of vertices. That data is all taken from Blender, export as GLTF with the animations. Then you have that data, you can then use that to transform your meshes in real time. So for example, there's the fire animation, there's the reload animation for this gun. There's also a revolver in the game. There's the fire and reload animations for that. So yeah, pretty straightforward. It can handle multiple instances running at the same time. It's not particularly efficient at the moment, unfortunately. It's something I need to work on. Let's do 30. I'll activate the basic enemy AI here. So at the moment you can just sort of run around and kill enemies, and these enemies I've made myself. They're quite crude looking, as you can tell. It's basically just a bunch of basic geometry made in Blender, but I fully animated. Every animation in the game I've created myself. Some of the other assets I've bought the commercial rights to. I'm using those as placeholders, I think, depending on how quickly I can learn to actually model things in Blender. I'm not very good at it at the moment. But yeah, anyway, back to the skin mesh system. As you can tell, there's multiple instances of these different creatures running around, and they're all animated independently. And they have a considerably big impact on performance. And currently the skin mesh system is by far the worst performing part of the game engine, and I've managed to track it down to one particular function, which is the function that applies quaternion rotation and transformations to the different bone matrices. Still struggling to optimize that function, but yeah, hopefully when and if I manage to optimize that, you can have potentially hundreds of different creatures running around chasing the player. And then lastly on Vulkan is the particle projectile simulation. So as you can tell, when I fire the gun, there's projectiles that fire out. There's also a flash effect, and that's also done through projectiles that have a far lower lifespan and far lower maximum distance and so on. So it spawns a few thousand of those out of the barrel of the gun at high speed when it's fired, and it creates a nice flash effect. The spray for the weapons is just done using a normal distribution. So as you can tell, it's very unlikely that you'll get the same sort of spray pattern for each gunshot. I don't know if that's a good or a bad thing. I think a lot of players, like from CSGO, they prefer to kind of learn the spray patterns for weapons. So maybe that's something that I'll implement later, is a sort of predefined spray pattern that high skilled players could learn. Also, there's flash effects when a projectile hits the ground. You can see it spawns a flash. It's kind of cool with the shotgun. You can see the cascade of flashes over the surface. And when you hit a mob, it spawns a different kind of flash, which is kind of simulating blood, I guess. Although the game isn't meant to use blood, it's meant to use memory, because the whole idea of the game is that you're inside a computer that's in the midst of a kernel panic, and your job is to deallocate enemies and reclaim memory from them, and the enemies are kind of resemble bugs. The hitboxes for the enemies and the player is fully operational though, so they are actually technically hitting the player's hitbox, and those hits are registering. So that's implemented. I just have not implemented the call to the player damage function, so the player doesn't take any damage. Okay, so sound's currently on. There is currently a simple 2D implementation of the Fmod Studio API that I put in with some very basic wrapper classes. I've just written that from the Fmod API reference. It's really well documented, very straightforward, well, relatively straightforward. So it was pretty simple to get that up and running. Currently only 2D sound is implemented. So here there's the shotgun sound, there's a reload sound. And the chamber spin sound for the moment is just the sound of me running a piece of metal over a computer keyboard. What's next? AI, movement logic, combat logic. Yeah, I mean, there's not too much to say about that at the moment. Turn the AI back on. Currently, all the AI does is it just sort of runs around the environment dynamically, pathfinding its way around the different objects in the environment. When it gets within a certain distance of the player, if it's within tolerance in terms of orientation and angle, it will launch a forward attack. That forward attack, after a delay, spawns an attack hitbox, and that delay corresponds to the animation. So you can see there's sort of a little wind up where they go back and then they go forward. So there's a slight delay where the player could theoretically dodge the attack. Then the attack hitbox comes in, the player registers it. You know, there's a simple collision detection between the two hitboxes. If there's a hit, then the player takes damage, and so on. But yeah, you can see that they're pretty decent at moving around the environment here and following me, which is pretty cool. Gets a little bit buggy if I get them all together. If there's many of them, they'll start to kind of go inside one another, even though they are also dynamically colliding with each other. Let's see if we can get some good shots of them running around. Yeah, it's working well enough for the moment, but there's no interesting logic like, for example, try and surprise the player by coming up behind them, that kind of thing. There's yeah, nothing too special at the moment. What next? Collision detection system. Okay, so this is the thing that I'm relatively proud of at the moment, just because it's working very smoothly, although it's fairly basic. Just uses a sphere, so you have the center point of the player in 3D space, or the mob, or whatever it is that's colliding with the environment. You take that center point, you've got a radius, determine the radius based on the dimensions, and then use that to check inside the hitboxes of the environment. And then what you do is, to stop the player just hitting the surface and sticking, is you take the normal angle of the surface that the players collide with, and then you use that to determine what is the sort of residual angle on either side, and therefore that lets the player slip off the edge of the surface like this. So it's literally what is the normalized direction of the player going into the surface, and then you take that and then you minus the normal of the normal of the surface, and then anything left over, that then becomes the player's sort of net direction. So if I'm not moving at all, the net direction is 0, but as you can see, as I start to turn a little bit more in any direction, then I can sort of slide off it. There's no collision currently for weapons, so as you can see, the weapons just clip right through. But as far as the player and AI is concerned, the collision detection is actually working really well. So I'm quite happy with that so far. Currently, only collisions in the XY domain are considered, where Z is up. So at the moment, the player isn't even colliding with the floor. What they're doing is they're just clamped to the nearest object beneath them.